Welcome to our program, Astronomy for Everyone. This time of the year, amateur astronomers start to think about the types of goodies they'd like to find underneath the Christmas tree. Yes, it's that time of the year again, and time once again for our Astro Gifts for Astronomers show. With me here in the studio is Jeff Heinlein, and he's with Great Red Spot Astronomy Products. Jeff, welcome to the show.
Thank you.
Now, we're going to talk about several different types of equipment during the show. We're going to cover binoculars and telescopes in the first segment, and then a little bit later on, we're going to talk about some of the accessory items that we astronomers are so fond of. But Jeff, let's start right over here with this pair of binoculars. Now, to start out in stargazing, this would be a great place to start before spending a lot of money on a telescope, right?
Binoculars are one of the best places to start with beginning astronomy because you don't have to know a lot about the sky or where everything is at. But it will allow you to see a lot of objects. It will help you to learn the sky. And like with many other astronomical equipment, you want to have a good quality eyepieces and aperture. These binoculars are made specifically for astronomy. As you'll see, they're bigger lenses than most binoculars you would see like at the local football game or sporting events.
Exactly. Mm-hmm.
And with that, it's going to be able to gather more light. This is also a 20 power telescope binocular versus your standard 8 power binocular like you might use at a field event. So again, it's going to be able to show you craters. You'd be able to see the moons of Jupiter with this. As well as deep space objects, nebula, and vast expanses of the sky.
Great. Now, I notice you have it here on a tripod, and that might confuse some people because they're most used to seeing binoculars being handheld.
Yes. The reason for the tripod on this is because of the magnification with this. At 20 times power, you would not be able to hold it steady enough to get a good view. So a binocular this size really requires the use of a tripod to give a good steady image in the eyepiece. And therefore you need to be sure to use a tripod.
Now sometimes I've seen with this type of a setup they use a parallelogram that helps, especially at star parties. That would be something that they could add that would allow you to move the piece to different heights and still keep your object in the field of view.
This one can to some degree as well. The tripod is adjustable up and down on this. It is a 3-part tripod, so it can go up to about this height if you're taller, or down to this if you're shorter, or even shorter for children.
Oh, it makes it quite handy.
Yes.
Interesting. Well, that was a good place to start. Next here we have this particular telescope on a very unusual mount. What can you tell us about this?
Okay, well, what this telescope is called a refracting telescope. It's what most people think of when they think of telescope.
Right, it uses lenses rather than mirrors.
It has the lens in the front, eyepiece in the back. This is an 80 millimeter Astrotech telescope. Very good for observing, again, wide portions of the sky. This is what's known as a wide field telescope.
Okay.
The mount that it is on is actually known as an alt-az, or altitude azimuth telescope, which means it's up and down and left and right.
Okay.
And this one is also computer controlled, so this one will be able to go to different objects if you tell it to go somewhere. So if we want it to move, it will go to, and this has up and down, left and right. It's all computer controlled. This has GPS in it, so it is able to tell you where you're at, sets it up almost automatically. You point it to a couple stars, and then you tell it what you want to look at. 30,000 objects in the database on this.
Very, very interesting. I say this is a very unique design for a mount, and what kind of a load is this mount able to carry as far as the weight of a telescope?
This can carry up to about a 32-pound telescope on here, so that's a pretty good-sized telescope.
That would take you up into the 6 to 8 inch aperture range?
Absolutely, 6 inch. Most of the time I use this one myself on here if I'm doing wide field observing of large parts of the sky, or I have a 6-inch telescope that I also put on here that then when I want to do more smaller objects in the sky.
Okay. This is very interesting. Especially I noticed that the mount seems to be quite steady with the tubular steel legs as well.
Correct. That, again, will go up to different heights, again, depending on what you are. So if you like to stand, you can also raise this up to a height where it's comfortable for standing. Or usually when I'm using this one, I keep it down low because then it's, you can sit on a stool and just have a really nice relaxing night under the stars.
Sounds like a great idea. This next telescope looks a little bit different, both the mount and the tube itself. What's the story behind this one, Jeff?
Okay, this one is called a Newtonian Reflector. It is a telescope that has no lenses in it other than what are in the eyepieces. This one works primarily on a mirror alone, so there's no eyepiece or a lens up in the front,
Okay.
but you do have a curved mirror or a parabolic mirror in the back, and then a small mirror in the front that brings it out to your eyepiece here on the side.
Okay, that small secondary set at a 45-degree angle.
Right, so there's a small mirror in here at a 45-degree angle that will reflect the image from the stars back up here to the eyepiece. This is called on an equatorial mount. They call it an equatorial mount because if you think of the planet Earth, it rotates on its axis.
Okay.
Okay? This axis points to the North Star on this telescope. So when you set it up and you are viewing an object in the sky, it will be able to track the star across the sky. This mount also includes a battery clock drive on it, so it's very simple. And so once you have the object in the view on this,
Okay.
it will also track across the sky. So you don't have to be constantly
Turning a
turning the
manual
knob in order
control.
to follow a star or an object across the sky.
Now, unlike our previous one that had a database of over 30,000 items, this one just has the drive that will keep that object centered in your in the telescope.
Right, in this one, the computer is right here. Okay, so you're going to have to know a little bit about the sky to use this one, but this is a very good entry-level telescope. They're not expensive. They're very reasonably priced for most people, and they're a good place to start. This is a little bit higher end scope, but this one will also track the stars as well. But this one goes to the star, so you don't even have to see it in order to be able to use this one. This one will also go to stars that you can't see, but you have to use a method called star hopping, in which you go from one bright star to the next bright star to the next bright star, and then finally to the object that you're going to be looking for.
And of course, you could use the finder scope here to help you zero in on that object.
Correct.
All right, very good. And this tripod is also adjustable in height as well?
Correct. So it'll go up again to about a 4-foot level or about 4.5 feet up to the eyepiece.
Very interesting, very interesting. A very nice looking little scope. And what's the aperture?
This is a 4.5-inch telescope.
4.5 inches, okay. And the one that we were just talking about, I think you said was 80 millimeters?
This is 80
Which
millimeters.
is about 3 inches roughly?
I think they call that a 3.4 inch.
3.4. All right, well, this is a great collection of scopes. I see we have one more right behind us, and of course it's the biggest one that we have here in the studio. And tell us all about this one, Jeff.
Okay, this is called this is a Newtonian telescope again. So these two scopes are basically the same telescope except
The same
larger.
construction idea. but-
Right.
Right.
So it's a 8-inch telescope. So there's an 8-inch mirror, 45-degree mirror in here. This one is the same principle as this one because it has the altitude and azimuth on it. So it's basically up and down and back and forth. No computer on this one, again.
Okay.
But the advantages on this one is going to be the larger light grasp. With telescopes, the larger the telescope, the more photons you're going to be able to collect. The brighter the objects, the more you'll be able to see in it.
Right, that's one of the fallacies I think a lot of people have about telescopes. So much is advertised on power, ridiculous numbers, 700, 1,000 power.
Correct.
And that's not what's important. As you said, it's the aperture, the light gathering.
Most of the time, even on a scope of this size, this is an 8-inch telescope, on a good clear night, I probably would not use more than about 150 power. Most of the time, our Earth's atmosphere won't allow for even much more than that, no matter how big the telescope is.
And I notice here that for the eyepiece where this goes here, this seems to be, there's more to it than the previous scopes.
Yes, the other eyepiece on this one has what's called an 1.25 inch
Okay.
focuser on it, so the sizes of the eyepieces are 1.25 inches. And this is what they call rack and pinion. So there's actually a little gear and then two sets of gears in here that allow this to move the eyepiece focuser tube in and out.
Okay.
This one is what's called a Crayford style focuser, and that's, I can't remember the name of the gentleman other than it was Crayford. What it is a scope that will, there's no gears on this. It's all done by friction.
I see.
It's much, much smoother, much more finer detail. This has a 2-inch focuser on it.
Okay.
So you can put the 2-inch eyepieces in it. They're usually a much higher quality with the larger eyepieces as well. But it also has the ability to be able to put the smaller 1.25" eyepieces on it as well.
Jeff, this has been a fascinating discussion about the basic types of equipment, binoculars and telescopes. And if you have any questions for us about some of the products that you've seen here, please send us an email. You see our address down there at the bottom of your screen. And right after Term of the Month, we'll be right back with our segment on accessories. Don't go away.
Term of the month for December 2010, Winter Solstice. Now, the solstice is the time when the sun is no longer moving north or south, but it's also the shortest, roughly speaking, the shortest day of the year. In the winter, in the northern hemisphere, in the U.S., we call it the start of winter as the first day of the winter. In the diagram, you'll see that the solstice is, the winter solstice is where the northern hemisphere is pointed away from the sun. It's tilted away from the sun, and it's tilted at about 23 degrees and 26 minutes. You could think of it as 23.5 degrees, or you could think of it as 23 degrees. The tilt of the Earth causes the northern hemisphere to be cooler in the winter than in the summer. There is an effect, the Earth's orbit is not circular, but at the winter solstice, the Earth is actually closer to the sun, and we'll get to that next month a little bit too. So the tilt of the Earth is the primary cause of the seasons of the Earth. Now, the ancient cultures made various artifacts that were based on the solstice and other sorts of things. Stonehenge is famous, but in southern Ohio, which is nearby for us Michiganders, there's Serpent Mound. And this is a mound. It's not very tall. It's only like 3 or so feet tall, but it's 1,370 feet long. And it has various things that point in interesting directions, including the winter solstice. Now, we don't know how old it is. It might be 1,000 years old or 5,000 years old, but if it's 5,000 years old, then the North Star at the time would have been Thuban, which is the brightest star in the constellation Draco. And Draco is what this Serpent Mound resembles if you lop off the modern head and put him upside down. So anyway, the term of the month for December is Winter Solstice.
Welcome back to the program. Thanks, Steve, for that interesting information on Term of the Month. You're probably wondering, what am I doing here? Well, I'm charging a flashlight, and in this segment, we're going to talk about some of the accessory items that amateur astronomers would love to find under the tree. With me here again is Jeff Heinlein from Great Red Spot Astronomy Products. Jeff, you've got quite an array here on the table. Can you tell our viewers about what you've brought?
Well, one of the things, of course, when we're out under the stars is it's dark outside. Okay?
Yes, it is.
And we still need to be able to see things, and we still need to be able to read maps, charts, and so on like that.
Exactly.
So different things that we need to do is that we need a source of light.
Mm-hmm.
Okay. As you know, white light, if you go in from a sunny day into a dark room, it sometimes is very difficult to see things because your light, the bright light makes your eyes not adapted to the dark vision.
Exactly.
Okay? If you use white light at night, you also lose your ability to be able to see objects in the sky clearly and brightly. So astronomers like to use red lights, because that will not disturb the ability of your eye to be able to see dark.
Your
or what
dark
they call
adapted vision.
Correct.
Right.
So there are a number of different things that we can use for that. One of the things that we have, that I have, is called a red LED lantern, which when you turn it on, you can put this down on your table and put your charts next to it, and it will allow you to be able to read your charts.
Interesting.
And it'll be from bright to super bright, or if you want to use it for an emergency light, it has a flashing light on it as well.
Wow, that's really cool.
Also, if you open up your car at night, you want to be sure that you have your dome light turned off, because that's going to disturb other astronomers. This is made to be able to put in your car or in a trailer or in the back of your vehicle, and it's just a touch light with red LEDs in it like that, so that you can put that on the ceiling in your car and be able to see in the trunk of your vehicle or inside the car again without disturbing your night vision. We also have over here some other objects. This is a flashlight that is a red LED flashlight.
All right.
However, the nice thing about this one is one that works on a principle called Faraday's principle. It uses no battery. It works strictly on a magnet passing through a coil, and as you shake it, that energy of the shaking is converted into electricity, which charges up a capacitor in here and allows you to have a flashlight that does not use batteries.
Wow, very eco-friendly. Especially being out in the field, when a battery dies, nothing worse.
These are also good for being out in the field, because as you know, we get a lot of moisture and dew and fog and so on like this. These are completely hermetically sealed. They're 100% waterproof. You can drop it into a lake and go down diving to the bottom and bring it up, and there'll be absolutely nothing wrong with it.
That's great.
And that comes in both red, and then we also have the white version of this as well. So for anybody who might want to have something to just keep around the home, that's never going to need batteries, it's ready for use in a few seconds.
What's our next item over here, Jeff?
Well, this is, again, because we were talking about being outside at night and dew and fog and so on like this. What this device is called a Telrad. And a Telrad is basically a device that you use to point up at the sky, and it will project a set of circles out into the sky. It's kind of like a heads-up display in a jet fighter. And that allows you to point the telescopes to different parts of the sky. The problem is, though, is that if we don't have some kind of protection over this piece of plate glass, that will dew up. And as you look through it, then you won't be able to see the stars or the sky. So this is called a dew shield. It's a Telrad dew shield, and this device that we're using to point as a pointer is called a Telrad. This will keep the dew off of that piece of glass in there, and this plastic will instead dew up. So when you want to look, you just flip the cover up, and then you point your telescope and flip it back down.
Pretty ingenious. Pretty ingenious. What's this 45-degree angle piece here?
This is a very important piece. If you remember when we were looking at the one telescope earlier, the 80-millimeter refracting telescope that's over here in the corner. In order to be able to look at that, this makes viewing comfortable, because it will take the image from the lens, reflect that in at 45 degrees, and then straight up, so that you look like this.
You can just bend, rather than having to do
like this.
Yeah.
Yes.
Right.
And that's a necessity.
Right, especially with not wanting to get a sore back. Could you use some of these eyepieces here that are on display in that unit?
Absolutely. We have various eyepieces depending on what you want to do and look at, from high-powered that will fit into here, as well as low power. This happens to be a very high-powered eyepiece, so if you want to be looking at planets or something like that.
Planets, or maybe even splitting double stars?
Splitting double stars, correct. This one is made by Vixen. They're a very high-quality Japanese-made eyepiece. As you know, the Japanese are considered to be some of the finest optics in the world.
Yes, I've heard that.
This one is made by Teleview. This is called the Ethos, and this is one of the newest eyepieces that are out on the market. One of the things that you look at when you look in an eyepiece is how much of the sky can you actually see when you're looking in the eyepiece.
The field of view.
That's called the field of view, as you say. This has one of the widest fields of view in the market. This one has a 110-degree field of view versus this one that has a 68-degree field of view.
Substantially more.
Substantially more. This is made by Teleview. The man who designs this telescope is Al Nagler, and he actually designed the imaging system that was used in the trainers for the astronauts for the lunar excursion modules.
Really? I didn't know that.
And this 110-degree field was the exact same field of view that were used in the projectors for the astronauts when they were training.
Interesting, interesting. And now it's brought out to the marketplace.
Right.
And
So this
can
is
take
another
advantage
example
of this. Yes.
of space technology coming to the average person again now.
well, that's great. That's great. What are these next couple of items here?
Well, these are filters, and many objects that you look at in the sky, you can barely see them or not at all unless you are using specialized filters. And the filters will cut out broad spectrums of light and pass only a very narrow spectrum of light. This one is called an oxygen-3 filter. This is probably one of the more used filters. That one and another one called an ultra-high contrast, which will have a very narrow band of a bluish-green kind of a color.
Okay.
So if you were to say, most of us are probably familiar with looking at the Orion Nebula.
Yes?
And if we were to put this in the telescope and look at the Orion Nebula, you would see a lot more detail and a lot more expanse as well. Some items you cannot even see without this filter. For example, there is an object that's up in the summer sky called the Veil Nebula,
Okay.
which is the remnants of an exploded star. And when you look at it, it looks just like filaments, okay? But if you look at it without a filter, you can just see maybe there's a little bit of some cloudiness there. But once you put the filter in there, you start to see all the different folded filaments as they revolve around each other. Then we also have here what's called a polarizing filter. And it works just like polarizing sunglasses. It's two opposing pieces of glass with different polarization. And it allows you to lighten and darken objects. When you look at the moon in a telescope, it's going to be so bright it's actually going to almost hurt your eyes.
Very
It's so
bright indeed, yes.
because your telescope collects so much more light than your eyes do. So by putting this filter into the light path in your telescope, either on the eyepiece or on the focuser, you can darken that down by about 95 to 96%, and it makes the viewing of the moon and bright objects much more comfortable.
Dims that down. In the time remaining, there's something that I want to be sure we cover with our viewers, and it's something that's got me kind of excited. This object right here.
This is almost a must for most astronomers these days, and that is the green laser. This is a laser that if you use to point to the stars, it'll be just like a lightsaber pointing out to the stars. So if you are having friends who don't know where you're looking at, you can point out where you're looking at in the sky with that.
Okay.
You can also put it on a telescope with a mount and then use that as a pointer so that you don't have to look through the telrad or the
regular
finder
viewfinder.
tube. Right, and so that way you can just be looking up in the sky and point your telescope and see it.
Of course, we always want to be safe when we're pointing lasers into the sky, make sure there are no aircraft in the area.
Absolutely, and then one of the features of this laser, because of that, is the safety. So this has safety interlocks on it built in as well, so that it can be sure that it cannot be turned on. You have to turn the key on, and you have to open up the shutter, and you have to press the button before it'll go on. So it has
So a
triple.
child can't find this and start aiming it around where they shouldn't.
Correct. And these come with rechargeable batteries in them as well, and it also includes the chargers on these. These are both come with a lithium-ion rechargeable battery and charger.
I see we have a couple more items here in our last minute or so in this segment.
Yes, again, we were talking about the different lights. One of the things that I have here too, for those, because you're carrying around a flashlight and trying to do too many things with your hands, this is a clip-on light. You can either wear it around your head or it'll clip on the brim of your hat, and it is a red light as well. So it allows you to read the maps.
A hands-free red light.
It is a hands-free red light. Another eyepiece, 100 degrees.
Okay.
This is again, another laser, but this combines several objects, and this is one of my personal favorites. I use this more often because it is the green laser as well. And it is a red flashlight with 3 different levels of red so that you've got your night vision. And then when you're putting things away at night, you've got your white flashlight with it. So you don't have, there's no need to carry around 3 or 4 different items. This combines them all into one.
That's fascinating. You know, hopefully I can find all of these under the tree. I know that's not possible, but I can always hope. If any of you would like to check out more of this type of information and products, come onto our website. We'll have the email address for Jeff there. And right after this, we're going to bring you our segment on What's Up. So don't go away.
What's up for December 2010? We start with the moon. On the 5th of December, we have the new moon. We're not going to be able to see the new moon that much, but shortly after the 5th, you'll see a thin crescent, perhaps. The 13th of the month is the first quarter. This is a great time to see the craters along the terminator, the day-night shadow boundary on the moon. The moon is full on the 21st, and the 21st also has another treat for us. At 3 in the morning, we have a total lunar eclipse. We have an eclipse of the moon. The Earth's shadow goes right over the moon, 3 o'clock in the morning. And then finally, on the 28th of December, we have the third quarter, so the moon is a morning object. We have, in the first half of the month, we have Mercury and Mars very, very, very low to the horizon. Mercury is tough to see. On the 7th of December, Mercury and Mars, but the moon also joins them, all kind of in a line. Now, on the one hand, the moon helps you find Mercury easier than it would normally, but it's so low to the horizon that it will be extremely difficult. You need a very clear horizon, western horizon. So just after sunset, then you can look toward the west. The plane of the ecliptic is at a very shallow angle, and so even though it looks like the moon and Mercury and Mars are quite a ways away from the sun, they're still very close to the horizon. Jupiter is the king of the planets in the evening. And as a treat, all through this month, the planet Uranus gets closer and closer to Jupiter for the entire month. So toward the end of the month, it's less than a thumb's width at arm's length away from Jupiter. So with binoculars, Uranus is extremely easy to spot because you've got bright Jupiter to guide you. Use a sky chart. You can get them online. Sky and Telescope magazine publishes them. Astronomy magazine publishes them. Neptune isn't that close to Jupiter. It's in the constellation Capricornus, which looks kind of like a smile. December has a meteor shower called the Geminid meteors. The Geminid meteor shower, and it peaks on the 13th. Now, any meteor shower, it may have its peak, but a few days before and a few days afterwards, you'll be able to see them. The Geminids are quite consistent, and this year we expect somewhere between 120 and 160 meteors per hour. So it's quite cold. Dress extremely warm. Go out to a dark sky site if you can. These meteors are relatively slow at 22 miles per second, and they come from an asteroid called 3200 Phaethon. It's the only meteor stream that we associate with an asteroid. And that is what's up for December 2010.